And there are some geometries, some parts and features that simply can't be made with traditional manufacturing processes such as CNC milling or lathe operations. Are you sure that you want to give up engineering? You spent a long time becoming an engineer. It really kind of relies on five things. One is making sure that you understand your long-term goals. These are usually in the 1 to 3 year range, right? These are the high level objectives. What are we really trying to accomplish? One of the limitations for me personally was there was a pretty real cap on what you can make as an individual contributor, as an employee, versus starting your own business. The possibilities are nearly endless, right?
All right, Aaron, welcome to the show.
Thank you so much.
Cool. Today we'll talk a little bit about pipeline design and engineering, which you have on your shirt right here.
I
So you
do.
founded a company a while back. Can you tell us a little bit about yourself? What's your background and what made you decide to actually start an own company, which is actually a big thing?
Yeah. I kind of fell into it. I am a mechanical engineer by education and have a master's degree in bioengineering. So about 13, 14 years ago, I was working as an engineer for a company here in Arizona. Great company and lots of smart people there. And I found myself disengaged from the work. I had been working there only for about maybe 3 years or so. This is the first job I got right out of school. And in the beginning, I really liked it a lot. I got to do all the things I love to do, building prototypes, designing in CAD, things like that. But over time, I found that I was becoming disengaged from the process and my heart wasn't in it. And these were really smart people that worked at this company. So they picked up on that. This was about the same time as here in the US, the 2008, 2009 recession was going on. So work started to slow down for them, and they had to make some tough decisions about, are we going to keep everyone or are we going to, unfortunately, let some people go? And because I was clearly not 100% engaged at the time, they made the decision to let me go. And I remember that being so incredibly difficult. I felt sick to my stomach for several days. My wife and I had just had our first child. We had bought a house, and so we had a mortgage payment, and I'm supporting my young family. And I'm thinking to myself, how am I going to do this? And I have no income now. About the same time, I had started exploring different professions or different career paths altogether. I had started a photography company with a friend of mine, and we'd been doing that for a couple of years, and I was really into that. And I'd also been doing a little bit of web design on the side, just on my own. And I even started looking into commercial real estate. I mean, very, very different things, right, than engineering. I thought that I just didn't like engineering anymore because I had become so disengaged with the process. And one evening, my father-in-law pulled me aside and he says, "Hey, are you sure that you want to give up engineering? You spent a long time becoming an engineer." And he suggested that maybe it wasn't engineering that I wasn't liking so much. Maybe it was just the way in which I was doing engineering. And that made a lot of sense to me. So I thought, maybe I should give this another shot and just try it on my own. So I knew some people in the industry because I'd been working as an engineer for several years at that point. So I reached out to them and I said, "Hey, I'm freelancing, doing engineering design work. Do you have any projects I can help with?" And a couple of people I reached out to said, "Yeah, we do have a couple of little projects you could help with." At the time, I'm sure I was a great deal. I was dirt cheap. I hardly charged anything, just enough to barely scrape by. And so I got a few little jobs right off the bat. And I was also still doing the photography thing and a little bit of web design. So I had a little bit of income coming from there as well. And between the three of them, engineering, freelancing, and photography and web design, managed to scrape by and make enough income to pay the bills. And I thought, this is great. I get to do what I want to do. And all of a sudden, I realized that, hey, I really do still love engineering. And it took me a long time to understand what had happened there, why I went from not being super interested in it, working at this job, to all of a sudden being in love with engineering again. And what I came to realize was that I don't do so well being, I'll call it a cog in the machine. You know, if I'm just one little part of this big machine and I'm mostly being told what to do by my boss or my supervisor, who are all well intentioned, no fault on their part, of course. That's the job of a supervisor or a boss, to give you tasks and tell you what to do. But I found that was just not a very conducive environment for me to thrive. However, when I got to own the entire process, so when I got to not just be the cog, but be the entire machine, I really thrived, and that was pretty transformational for me. And all of a sudden, I loved engineering again. So that's kind of my story of how I got to where I am now. My company is Pipeline Design and Engineering, and that was about almost 14 years ago that I got laid off and started doing my own thing. I pretty maybe a year or two thereafter, I stopped doing the photography and the web design because engineering got so busy. Eventually, I brought in contractors and then full-time employees, and we're still a small team. There are about 20 of us right now, 20, 25 if you count contractors as well. And I just love it. You know, every day I love waking up and being an engineer.
That's pretty cool. What are you actually doing at your company? So what are you producing, or like are you offering services as well? I think I've seen it on the website, right?
Yeah, thank you for asking. We do custom equipment. So if a customer is maybe manufacturing a product and they need either a novel way to manufacture this product because there's no equipment out there that does it right now, or maybe it's a standard manufacturing process, but they need a way to install something, to assemble it, or to test it. We develop the custom equipment, fixtures, and automation that enable these custom processes.
That's pretty cool. Can you maybe name a few case studies? I think for the engineers listening to this, they wanna delve a little bit deeper into the topic. Maybe a few
Yeah,
case studies that you could mention.
definitely. One that we recently did was this carton erector. So it's a box, basically a package for. It was a medical device, and the customer's technicians would do this manually. They would erect the carton, pop it open from its flat state. You know, they receive it flat from the supplier, and then they have to pop it open, erect it. And then they fold the tabs closed on one side and they stuff it with a product. And then they fold the tabs closed on the other side and put a label on it and send it out to a customer. Well, that action of erecting the carton, so just popping it up from its flat state to its erected state, was causing repetitive stress injuries in these
Hmm.
operators. Think about doing that motion over and over and over for 8 hours a day, every day. And these cartons, they're kind of thick, and so it required some force to erect the cartons. And over and over, that was causing repetitive stress in these poor operators. And so the company, being very responsible, identified that as a health issue and said, we need to resolve this. Let's take care of it. So they started looking on the market for automated carton erectors so their operators wouldn't have to do this manually. They couldn't find any. Now, carton erectors certainly exist commercially. You can go out there and buy a carton erecting machine, but these are typically for Amazon style boxes, these brown cardboard boxes that are more standard shapes and sizes. The cartons that our customer are working with, are very unique to their product, and they're thin. They're maybe 3/4 of an inch tall when erected, and they had different sizes. They had square cartons, and they had really long, skinny cartons, but they were all very thin. And there was just no machine out there that would perform this process of erecting the carton and folding the tabs. So they approached us. We've been working with one of their other divisions anyway, so it's kind of a warm intro, and said, hey, we need this automated machine. Is this something you can help with? And we said, yeah, absolutely. This is what we do. So we were engaged to develop this machine, and we spent the first probably 2 months, 2.5 months, just doing process development work, benchtop R&D, where we had kludged together this contraption that was consisted of some 80/20 and some really cheap linear rails and carriages just to provide smooth motion. And using this benchtop apparatus, we came up with a process that worked for erecting erecting the cartons and folding the tabs closed. And it was all manual, right? Because it's all benchtop. We didn't want to waste time automating it right off the bat. We wanted to figure out, okay, what is the set of motions that is required to erect and fold the tabs closed in this carton. And once we did that on the benchtop with this manual rig, then we went into CAD. We used SoildWorks, and we transferred what we learned on the benchtop into a CAD design that accommodated automation as well. So we implemented the core functionality of our benchtop rig, and then we added motors, and we added air cylinders, and we added sensors and things like that to automate everything. And once the design was finished, we started building this machine. It was a pretty cool machine. It ended up having over 300 unique part numbers. So there were plenty of off-the-shelf items, just your standard screws and motors and things like that as well, but also over 300 unique part numbers, so custom parts that we had to design from scratch because they just didn't exist anywhere. All told, I think there were over 700 custom parts that we ordered. About 300 of them were unique, and then there were multiple quantities of some of those. So quite a few custom parts, and then all of the off-the-shelf parts, of course, as well. It had a universal robot, UR robot, that was mounted to the top of a large welded steel frame. And this robot comes in and it picks up these flattened cartons from a magazine, replaceable magazines or reloadable magazines, picks them up, and there's a barcode that gets scanned to ensure the correct orientation of these cartons has been achieved. So the barcode is supposed to be in a very specific place, and it will be if it's in the right orientation. It goes past a bar scanner to read that barcode, make sure it's in the right orientation. Once that happens, it goes into this long tooling bed. And the tooling bed is pretty neat because it accommodates both the square cartons and the long skinny cartons, and it will dynamically adjust based on what you're running. So the whole tool bed will widen or become more narrow depending on what carton you're running. And then there's suction that's used, vacuum systems, suction cups to erect those cartons. And then there's a pretty cool set of movements that we identified and developed that will close the tabs on one side. And then the robot picks it up and it drops it off on the operator's table on an output tray. And the operator then stuffs it with product and closes the tabs on the other side and then sends it out. So that was a pretty neat project. You can actually see it on our website right now. It's in the case studies location. But that's an example of custom equipment that we've produced.
In terms of custom equipment, what would be interesting for me is you talked about building things from scratch with like 300 to 700 parts, but how much of it, like percentage-wise, maybe a rough estimate, how much of it is actually templatized? So someone comes to you, they want to have something customized. How much of it can still be templatized, and how much do you have to do from scratch?
So that's a really great question. A lot of it truly is from scratch because these machines are so custom that there's just no way to templatize it. One of the problems that we have, though, is there is always a chasm, not always, there's often a chasm between what a customer is willing to pay to develop this custom equipment and what it actually costs to do so. And oftentimes that chasm is unbridgeable. In other words, the customer is simply not willing to pay, or it's not worth to the customer what it costs to develop this custom piece of equipment. And so I spent a lot of time thinking about how can we make this process more affordable and reduce that chasm so that we can help more customers. And an idea that I've come up with and we've actually been pursuing over the past 6 months is something called design accelerators. And this is a new concept within the world of CAD. I have not seen it done anywhere else. Design accelerators are Are you familiar with low code, no code, that trend going on in software? Yeah. Okay, great. So for those who aren't familiar with low code, no code, it's basically building blocks that can be used to create software applications. And there's typically some integration that goes along with that. But instead of writing your code from scratch, there are these pre-made blocks of code that you can just drag in and they do their own function. And I thought, why don't we have that for CAD, right? Why couldn't we do that for CAD? So these design accelerators that I mentioned, that is the CAD analog to the low code, no code trend in software. And again, if you go to our website, I think we only have about 9 or 10 published right now, but that's about to double in the next few days. We just internally released another batch. We have a bunch of these design accelerators that folks can download for free right now. And we are beginning to use internally to, as you put it, templatize that process and make it faster and less costly. And an example of a design accelerator, oftentimes in the equipment, the machines that we develop, we have to hold a device somehow. We have to hold a device in order to inspect it or test it, or maybe to assemble part of it. But at any rate, we need to hold a device somehow. So in the past, we've designed these device holders from scratch all the time. And depending on the complexity of the device, it might take 1 or 2 days to develop the holder for this device. It's just a simple contoured cavity within a larger platform in which your device rests and nests, and usually some toggle clamps to kind of hold it in place, but holds the device in a very specific location that will never change. And it's very repeatable for an operator to put another device in there. It will always be in the same position, same orientation. So these device holders, again, would take maybe a day or two to design from scratch. What we did is we took an older design holder that we developed and we templatized it. We said, all right, what are the elements that are almost always in here that we shouldn't be designing from scratch? And those are things like the overall shape, toggle clamps to hold the device in that contoured cavity, the mounting features, whether they be fasteners, or we use these really great quarter turn fasteners that require no tools in order to mount the device holder into your workstation. And we put those features into this model in a way that's really easy to configure them. So, of course, not every device holder is going to mount with the same mounting hole pattern. And so it's very easy to change the mounting hole patterns. It's very easy to suppress the screws for mounting and unsuppress the quarter turn fasteners for mounting. It's very easy to move the toggle clamp positions around. It's very easy to make this holder either designed to be used upright or vertically or flat. So there are some elements that can very quickly be reconfigured. And now, instead of taking a day or 2 days, it takes maybe 30 minutes to reconfigure this device holder. And you've got this great, semi-custom holder that can be installed in almost any machine or piece of automated equipment. And that's just an example. So you're going from 8 hours or more to about 30 minutes by using this design accelerator of a device holder.
Interesting. In the whole workflow that you've described, what's the most challenging thing you would say?
Well, there's this balance between how much do you templatize something versus leaving it open for customization. And it's a struggle to figure that out, right? The more general you make it, almost the harder it is to integrate. But if you make it too specific also, then it's also harder to integrate into a larger system. So finding that balance is tricky. And I think we're still learning how to do that. We're still kind of early on in the process of figuring out the best way to develop these design accelerators.
How do you price your services? I know on the website there's a few things that you could buy in terms of services, but how do you approach pricing in general? So for example, a customer comes to you, they say, I want to have this specific thing. And how do you price it in the first place? So do you have like a baseline price and then increase basically by a range of what you would add on top of that? Or how does it work in your business?
This is tough. This is something we've also struggled with over the years, is finding a way to price our services that allows us to make a profit, but also is affordable enough for our customers. And we have a few different ways of doing this now. So we have developed several different approaches depending on the customer. The easiest way, and what we like doing, is what's called time and materials. And so we have an hourly rate, whatever that rate is, and we just bill that rate against the number of hours that are required to complete the project.
Mm-hmm.
Everything we do is custom, so it's really hard to say this project is going to take 500 hours or this project is going to take 1,000 hours. There are always roadblocks that come up that we didn't expect. We're inventing things, and there is inherent risk in that. So we give customers a good faith estimate and say, we think it's going to be about 700 hours, and here's the hourly rate. And so you can do some simple math, and that's the cost. And there are some expenses associated with what as well. We're going to have to build some prototypes and things like that. Sometimes customers are fine with that approach. Other times they say, well, I don't want any ambiguity in this. I want to know exactly how much I'm going to pay by the end of the project. And that's really tough because we don't know exactly what it's going to be by the end of the project. So another thing that we've done is we'll quote projects in phases. And that's a good way to reduce risk on both our part and the customer's part. We might be able to identify 3 different phases. Maybe the first phase is just a conceptual design phase where we'll put together a few kind of cartoon CAD is what I call them, concept designs. We'll present them to the customer and say, what do you think about this? What's your feedback on that? And we'll get some good back and forth, some good feedback and direction there. And that phase can be quoted relatively inexpensively, maybe $5,000 or $10,000. And after that phase, maybe we'll just quote that phase as a fixed price. Maybe it's $7,500 for this first phase. And then the second and third phases, we'll say, we don't really know. It depends on how the first phase goes. But yeah, we think maybe the second phase is somewhere between $50,000 and $100,000. And the third phase is maybe another $70,000 or something like that. But we'll be very clear that there's significant margin for error in there because we don't exactly know. But then after we do the first phase, which is relatively low risk for the customer, right? Maybe 5,000 or 7,500, whatever. That's not a huge commitment for most of our customers. And at the end of that, they'll have some concepts. We'll have had a chance to talk a little bit about different approaches and what the requirements really are to narrow the scope. And at that point, it's a lot easier to say, okay, now we can give you a much higher level of confidence, quote for the second phase, and maybe we will do a fixed price for the second phase. So those are a few approaches that we've developed. I mean, a lot of people, kind of use these approaches. We've learned that it is really, really dangerous to quote a custom machine design project as a fixed price right from the get-go without doing any of the early conceptual phases. There's just too much that we don't know, frankly, too much the customer doesn't know. It's very common for scope creep to occur and for the customer to realize during the process that, I want this thing that I didn't know I wanted in the beginning. And so it's dangerous to just quote a project fixed price from the beginning without having done that early phase.
Yeah, that's super interesting. What is the cheapest and the most expensive project that you've worked on?
Well, we've done some... I'll say that generally speaking, we don't take on projects that are less than about $10,000, but we have some customers who are longtime customers of ours and are really wonderful customers, and we want to keep them happy. So occasionally we have a customer right now, actually, who's been a longtime wonderful partner, customer of ours, and they have an approved supplier list, and they can only order things from their approved supplier list. Of course, we're on that list, but occasionally they come across a vendor who has a unique offering that they really need, but is not on their approved supplier list, the ASL. And it's a lengthy process for them to go through adding a customer to the ASL. It takes a lot of time. They incur a lot of cost. And oftentimes it's just the time associated with it. It might take a month or 2 months and they don't have that time. So they're hiring us right now to place an order with this customer. And it's like $300, it's almost nothing. But we're on the ASL already, so it's kind of a loophole for them, and they get to immediately place an order for this unique product or service that they need. So we've done very inexpensive projects under $1,000 like that, just to help out customers that we already have. On the other end of the spectrum, into the millions, multiple $1 million projects that are going on.
It's crazy.
Yeah.
I was wondering from an engineering perspective. So you manufacture the pieces that the customer needs. How do you verify and validate the design? For example, do you use things like finite element analysis, things like that? Maybe you can give us a little bit of insights there.
Yeah, for sure. We do have some FEA capabilities. Typically, what happens though for validation at the end of a project is you all start with what's called the user needs, and then the user needs trickle into technical requirements, and that produces a document called different things: the URS, user requirement specification, or the PRD, project requirements document. They're kind of the same thing. People call them different things though.
Hmm.
And you have this formal document that says what are the user needs and what are those user needs in technical terms. So a user need might be I don't want this device to fall out of my hand accidentally during use. And the technical requirement for that might be the handle shall have raised bumps that are a 1/16 of an inch in diameter, spaced by a 1/4 inch between themselves, that cover a surface area of 8 square inches in this area, something like that, right? Something that's measurable. And there's going to be a list of these things, different user needs, different technical requirements that meet the user needs. So at the end of a project, we will take that document, which we have been tracking, of course, throughout the duration of the full project, and we'll just go through them line by line. We'll say, okay, technical requirement number 1, has that been met? And sometimes that can be performed just with a visual inspection. Sometimes it needs to be measured with different instrumentation, but we'll go through this document line by line and make sure every single technical requirement and user need has been met.
That's interesting. So I would be interested in maybe the manufacturing side of things. What's the most complicated thing that you've encountered or encounter on a daily basis, maybe? Because I've seen a video from Elon, and he said that manufacturing is one of the hardest things ever as an engineer to do. So what's your perspective on that?
Yeah, I agree with him. What he's talking about is mass production, which truly is its own project altogether.
Hmm.
Most of the things we do are one-off builds, so we don't have to get quite as deep into manufacturing as Elon does or anyone else that's
Hmm.
is producing something at a very high volume. We're only producing 1 or 2 of something. So if something comes in and a hole isn't in quite the right position or a feature has been left out, it's pretty easy for us to just modify that one part and then we go
Yeah.
on our merry way. So in that sense, things are easier for us than they might be for a company that's producing something in a very high volume. Something that we leverage quite a bit is 3D printing. And there are some geometries, some parts and features that simply can't be made with traditional manufacturing processes, such as CNC milling or lathe operations or a weldment or thermoforming, plastic injection molding, things like that. And we make heavy use of 3D printing, which does allow to make almost any geometry you want. We have a
Hmm.
couple of 3D printers from a company called Mark Forged. Um, they're not paying me to say this. We just love using them so much. So I'm always talking about our Mark Forged machines. And these print with chopped carbon fiber within a nylon shell. Or they can also print with continuous carbon fiber. And especially when you print with continuous carbon fiber, the parts become very, very strong, approaching the strength of aluminum. So we use these Mark Forged machines to print complicated and simple parts for the machines that we design all the time. In fact, a lot of the final deliverables that we send out to a customer will have some of these 3D printed parts.
That's super cool. Super interesting. When it comes to going back maybe 14 years, 14/15 years when you started the company, in terms of time management, when you were struggling back then, I would be interested because I found my own company, as we've talked about before the podcast. How did you manage time in the first place, and what are your biggest time management tips, I would call it?
Yeah. So I have a little system that I've used that I've put together over the years for myself. And it really kind of relies on 5 things. One is making sure that you understand your long-term goals. These are usually in the 1 to 3 year range, right? These are the high level objectives. What are we really trying to accomplish? The next thing is to have some kind of tool, and I'll go through these in a little bit more detail, but I'll just give kind of a high level overview at first. Next thing is to have some tool that you can use to capture new tasks as you think of them. So you might be at the grocery store, right, buying food for the family or something, and you think to yourself, oh, I need to do this thing. And you need to have a tool to capture that so you don't forget and so it doesn't get lost. And then at the beginning of each week, you need to schedule some time for yourself to plan out your week. What are you going to accomplish that week? And then after you've identified the things that you want to accomplish, I think it's really important to actually calendar those items out. So you might have a task, do ABC, that gets its own calendar event. Do XYZ, that gets its own calendar event. And you put them, specific times and days, so you know exactly what you're doing on these days. And then finally, it's really important to reduce distractions. Most of us have smartphones these days, right? They're constant notifications, and we're using Slack or Teams or different messaging applications. We've got email going, there are phones, there are all these different opportunities for one to become distracted. And it's really important that we silence these things, or at least we have designated times during which we just silence all of the notifications. So it's almost impossible for someone to get our attention and distract us from what we're supposed to be doing. So those are kind of the high level steps. I'll go back to the beginning now, making sure you have these long-term goals. And I like to think of these as 1 to 3 year goals. So you might have a goal that, so we have these design accelerators right now. Maybe one of our high level goals is we want to have 50 of these done by a year from now, right? Mm-hmm. And then at the beginning of the week, as I mentioned, you take some time, maybe 30 to 60 minutes, to go through all the tasks that you could do and decide what you should do. And there are typically two sources for these tasks. One is your high level goals. These are your primary objectives, the long-term goals that you want to accomplish. And then the second is whatever that tool is that you have. Maybe it's just a notebook that you write things down, right? When you're out and about and an idea comes to you, you have this list of your long-term goals, and you have this list of these shorter term tasks that you've come up with. I like to use OneNote as my tool for capturing these thoughts. Mm-hmm. Because it's on my phone, it's always with me. It's easy to take out and just write myself a note. Remember to do this thing. There's another application called Airtable that's great, and that's also mobile friendly, and so you can put it on your phone. And I actually use both of these to capture these random little thoughts that I have. But at the beginning of it, every week, I'll take usually about an hour or so, and I'll look at my long-term goals, and I'll look at my shorter-term goals. I usually call these the operational tasks, right? There's kind of the small things that need to be done on a day-to-day basis. And first, I'll decide of my long-term goals, what can I work on this week towards achieving those goals? And I'll identify a few things, and I'll actually create calendar items. And then after I've identified and scheduled my primary goals, then I'll look at my OneNote or my Airtable, and I'll pull some of those things in. These are my secondary things, my operational goals for the week. And I'll schedule those as well. So if you look at my calendar after that first hour in the week, it looks like I'm super, super busy, right? It's just filled in everywhere. There are a few spaces where I intentionally don't schedule things because things always come up that you can't plan for. And so it's important to leave an hour here and there that's just free and available to take care of those things. But in general, if you look at my calendar, it looks like I'm just way too busy, right? Everything's filled in. But realistically, I'm not any more busy than anyone else. I just schedule all of these things out. And so I know every day exactly what I'm supposed to be focused on. And I also know that I'm focused on the right things because I've taken the time to not just from a reactive standpoint, fill in a bunch of stuff that I could do, but I've thought high level, what are my long-term goals and what are the things I need to do to achieve those long-term goals? So these weekly tasks are really rooted in the long-term objectives. So I know what I'm supposed to be doing, and I know that these are the right things to be doing. And then at that point, it's almost magic. You just execute. You just follow your calendar. Today, Monday at 10:30 a.m., I'm supposed to be working on this thing. All right, let's do it. Knock that out. Tuesday at 4:30 p.m., I'm supposed to be doing this thing. Great, knock that out. And it is amazing how effective you can be managing your time and working effectively when you have a plan like that. You know, they say if you fail to plan, you're planning to fail, and I think that's very, very true. So that's the process I use for time management.
Pretty cool. And how do you stay quote unquote productive? Because sometimes
It
there might be a lot of up and downs. So how do you stay productive, keep yourself motivated? And what actually motivates you in the first place? Is it like being on top of the game? Is it like money that motivates you, or what is it?
That's another thing I've thought a lot about. You know, if I'm being perfectly honest, money does motivate me. I like seeing a very tangible return on my investment, right, which is my
Yeah.
time. And that was one of the things that bugged me when I was an employee. And also, please don't misunderstand what I'm saying. Employees are wonderful. The world needs employees. This is nothing against employees. I could not survive without having the amazing team of employees that I have. It just wasn't for me. But one of the limitations for me personally was there was a pretty real cap on what you can make as an individual contributor, as an
Yeah.
employee, versus starting your own business. The possibilities are nearly endless, right? It really comes down to how hard are you willing to work, how much risk are you willing to take, and so that was very attractive for me to start a business and have much greater earning potential. That certainly motivates me. Beyond that, I, I take my commitments very, very seriously. And so if I tell someone I'm going to do something, I make sure that it gets done. And it keeps me up at night if, maybe I'm supposed to have something done a week from now and I'm thinking it's a week out and how am I going to get this done? I'm not sure quite yet. Uh, it keeps me up at night, and it is certainly a source of stress if I'm not where I'm supposed to be. I'm not on track to finish something, but I will do everything in my power to figure that out. And so meeting my commitments is something else that definitely motivates me. If I tell someone I'm going to do something, I absolutely find a way to do it no matter what. Um, and then it's funny, when I started my company, I had lunch with a friend and he asked if I was ever going to hire employees. And I said, no, there's no way. I'd like doing this just by myself. I don't want to be liable for anyone else. I just want to do my own thing. But now I can't even imagine doing this without the team of people that are working with me. And so something that motivates me is keeping them happy. The purpose we have at Pipeline is to promote joy in the lives of our team members. And it absolutely brings me joy when I can see team members here at Pipeline finding joy in what they're doing. So just this idea of helping others and keeping other people happy, that really motivates me as well.
That's cool. When it comes to the team, I would maybe have a little bit of a controversial question. How
Mm,
do you make sure the intellectual property is not being taken away from someone and they do their own thing, basically, become a
yeah.
competitor of yours?
Well, there's no way that you can truly do that with 100% certainty. We certainly have um, barricades in place to keep the honest people honest. We have internal agreements that team members all have to sign that basically assign any work related IP to Pipeline, the company. So there's a legal agreement in place for everyone. And this is something a lot of our customers require us to have as well, because sometimes we'll sign an agreement with a customer that assigns IP to them for anything we do. And so we need to make
Yeah.
sure that Pipeline owns the IP from any one of our team members who's helped develop that, so that we can then assign it to our customer. We've never had any problems with it. Fortunately, there's never been an instance when one of our team members has decided to go rogue and develop something on their own that they learned at Pipeline. It just has not been an issue. If it ever were an issue, the next step would be you get into some legal action, right? You would probably have to hire an attorney and sue someone if they infringed on your IP. But thankfully, it's never gotten anywhere near that level. So for us, it's really just down to these internal legal agreements that everyone signs.
Hmm. What has gotten you so far, Aaron, to this stage? Is it hard skills, soft skills, or maybe a combination of both? And what
Mm,
soft skills do you think the engineers will need to have, especially in the future?
yeah, that's an astute question. I think it has to be both. You have to have the
Hmm.
technical skills and you have to have the soft skills. However, the technical skills at a certain point become less important, in my opinion. There's only so far you can go with really good technical skills, but not good communication or soft skills. You could be the smartest guy in the room, but if you're a jerk and no one wants to work with you, then there are definite limitations for how far you can go. However, the opposite is not true. If you have good enough technical skills, but really, really good communication, soft skills, there's almost no limit to how far you can go in your career. And what I've learned is that those are really the more important set of skills is the soft skills, being able to communicate with people, being nice to people, treating people well, understanding how to respectfully negotiate, things like that. These are the critical skills that aren't taught at school, but are so important for anyone who wants to go far in their careers, whether it's just becoming an incredible individual contributor or going into leadership, management, things like that. So I think that there was even a study done. I can't remember. I can't cite the study, but I remember they measured the IQ of very successful people, and they found that there was a threshold. Your IQ had to be. It was something like it wasn't super high. It was like 110 or 115, something like that. But if your IQ was at least around that area, 110, 115, then that was all you needed as far as like technical ability, quote
Hmm.
unquote intelligence. And there are two kinds of intelligence, right? There's practical intelligence, there's analytical intelligence. So what IQ measures mostly is the analytical intelligence. So if you're at least at that threshold level, that's really all you need. You do not need to be a genius, which is good news for me because I am certainly not a genius. I kind of struggled in school a little bit. It was hard for me to do even well enough at engineering school. Um, so I think I'm actually a pretty good example of that. My technical skills are, they're okay, but they're not incredible. But I think I have really good soft skills. And just the communication is the one that always comes up, right? Knowing how to work with other people, knowing how to speak with them, knowing how to say something that's uh, not offensive, not going to offend people. That
Hmm.
I think if I were to concentrate on one area as an engineer outside of the technical skills, it would be communication, learning to get along and communicate with others.
That's cool. Yeah. And probably if they're not good of a communicator, you probably would say iteration, always iterations, like work on your communication skills, negotiation skills.
For sure. Yeah, I mean, you look at the world's best musicians or the world's best athletes. How did they get there? It wasn't by waking up in the morning and just being so naturally gifted that they could just do this thing all of a sudden. They
Mm.
practiced a lot. They put in thousands and thousands, maybe tens of thousands of hours of practice to get there. In the end, it's really tenacity that leads to success. You can be super smart, but maybe not so persistent, and you might not accomplish that much. But again, if you have that threshold level of capability, of intelligence, right? But you're willing to be really, really persistent, so tenacious, and just not stop until you figure it out. That's where the successful people are.
Mhm. If you would start over building your business, Aaron, what would you do different? And what advice would you give to people wanting to start their own business? Is it for everyone? I mean, we
It's
talked
not for
about it a little bit.
everyone. No, it's not for everyone. In the beginning, I routinely worked 60, 70-hour weeks while having, raising my family. So there were a lot of demands on my time. And luckily, my wife is very, very understanding and was supportive of that. But sometimes that's just not in the cards for everyone, right? Putting that kind of time into a business. So there's a
Mm.
huge time commitment in the beginning. And that lasted several years until I started hiring other people who could help with some of these things. So you need to be willing to put in the time for sure. If I were to do something over, what would that be? I don't. I was very hesitant to hire anyone for the first 4 or 5 years. I just had contractors. And I think part of that was just being worried that I wouldn't be able to support them. I talked about keeping my commitments earlier. Hiring someone
Yeah.
full time, that's a big commitment, right? You're promising this person that I'm going to feed your family for the foreseeable future. And that was scary to me. And so I didn't do it for a long time. I think it was 5 years at least before I hired anyone full time. I hired contractors, but that's easier, right? If the work dries up, you just say, "All right, I don't have any work for you, contractor." But
Mm.
an employee, that's a bigger commitment. I think maybe I should have been less concerned or less uh, hesitant to hire someone full time. What I guess what I've learned is that as soon as you can identify a pattern or a trend, in this case that there's revenue coming in regularly, it's okay to trust that pattern. And it's not
Hmm.
going to work out 100% of the time, right? But probably 90% of the time, 95% of the time, it's going to work out. So if you see a pattern, in this case, there's revenue coming in regularly, it's okay to trust that pattern and take a little bit of risk and say, I'm going to make a decision based on this pattern that I see. So probably hiring some people full time earlier on, that would have been helpful.
Yeah. What do you think is this threshold in terms of revenue to start looking to hire someone full time?
Well, that depends on probably your profit margin and what kind of business you're in.
Mm.
What I've seen is that for a services business anyway, and honestly, I don't think a services business is the greatest business model. It's kind of a tough business model to do, I think, at least in our industry. Typically, you can make about 2x what it costs to employ an engineer.
Hmm.
So if you're going to pay, $100,000 for an engineer after like all the employment taxes and like tools and equipment that go along with hiring an engineer, you might be able to make $200,000 in revenue from that. If you have products, I think that scale goes up quite a bit. You might be able to make 3x or 5x or even 10x. Probably Apple makes like 10x on their engineers because they sell so much of their product. So there's a rough scale, 2x to 10x of what it costs to employ someone. And that's just for an engineer. For different types of roles, that's going to change. I don't think there's not like a specific dollar amount where you can say, okay, at this dollar amount, now we can hire someone. It kind of comes down to how much profit can you make and how long is it going to take to make that profit.
Yeah, that makes sense. Cool. Aaron, anything else we missed in terms of like your company, maybe some closing remarks from your end?
Well, if you don't mind, I'd love to give a plug for my podcast. I actually do a podcast as well. It's called the Being an Engineer podcast, and you can find that wherever you're listening to this, as well as all the other typical places to listen to podcasts: Apple Podcasts, Spotify, Google, etc. And we talk about engineering, and we actually talk a lot about the soft skills, about how to communicate as an engineer, how to navigate the corporate bureaucracy and things like that, which personally I don't know myself because I've never really been at a large corporate engineering firm, but a lot of the guests I have been there. We've had some really amazing guests. We've had John Hirschtick, who is the founder of SoildWorks and now Onshape. We've
Hmm.
had David O, who was the project lead on the Mars Curiosity rover for NASA's JPL, Jet Propulsion Laboratory. We've had YouTube sensation The Hacksmith, James Hobson, on the show. So we've had some really cool people. And we've also had just a lot of, like regular engineers who are passionate about what they do and have pro tips to share about how to do the engineering work better, more efficiently, find more joy in it. We've got over 180 episodes, I think. So just Google Being an Engineer podcast and you can find us pretty easily.
Awesome. Aaron, thank you so much. I hope there will be a second part in the future. Who knows? Maybe we'll talk about more soft skills topics in engineering. But yeah,
Yeah, I would love
it's
that.
nice
Thank
having
you
you.
so much. I sure appreciate it.